For this video, we're going to use this prostate patient to demonstrate how to create a three-field plan. The first step will be to insert our plan. So we're going to come up here to Insert, New Plan. We do have a course available, C1, so we'll use that course. There is a Plan 1 already in there, so it's going to default to Plan 2 as the ID, which is fine. We're going to select our target volume, in this case prostate PTV. We do have an available reference point, so we'll go ahead and use that. Here we can create or pick or choose our treatment machine. We'll go with a TrueBeam for this case. And you always want to double check that your patient position or orientation is correct. Since this is a fairly central target again, we're going to use 15x or a higher energy beam. Okay, since we did select that target volume, it automatically puts our isocenter in the center of that volume. Again, if you wanted to move that, you can certainly do so by clicking and dragging in any 3 plane. First, let's add our DRR and RMLCs. So we're going to right click up here in the top right window, set beams I view to F1. I'm going to right click on our beam, new DRR, click apply. Now let's add our MLC. For this case, we're going to just use auto surround to place a 1 cm margin around our structure. Okay, so we have our AP beam set up with a 1 cm margin around our PTV. Let's create a new opposing field for our PA beam. Let's redo our auto surround. Now we're going to do a right lateral for this 3-field plan. So let's click on F1. I'm going to copy and paste that by using Control C and then Control V. You can rename your field, but I'm going to leave it default F3 for now. I'm going to come here to Geometry, and since I want a right lateral, I'm going to use a gantry rotation of 270. Okay, so we have our AP beam, our PA beam, we just added our right lateral. We need to redo our auto surround. Okay, we have our 3 beams. So let's put our prescription in. Let's do 300 times 10 for this case and compute. To turn off, so what this is right here, this is our dose in 3D. So I'm going to right click on dose, come here to isodose levels. I'm going to turn all that off. So I'm going to click up here, click OK, and all that will disappear. So the first thing we want to do is check out our beam weighting. So you can see here, if we look over here at our isodose lines, our high dose lines over here, or our hot spots, are all on this right side, and that's due to our right lateral beam. So let's see if we can click F3 to open up our field weights and adjust that to make it look any better. So F3 is our right lateral, so let's maybe try a little bit less weight from that right lateral. I think that probably looks appropriate, but our weighting is all going to depend on how we want our dose distribution to be. So if we added this right lateral beam, in this case maybe to avoid some rectal dose or bladder dose, we're going to adjust this weighting in order to meet whatever constraints we want for our rectum and bladder. So if we watch this, if I add more weight from my right lateral beam and click apply, you can see how those isodose lines get out of that bladder and rectum a lot. So let's look at this blue line, 80%. So 80% line is really hugging our PTV right here. If I drag this back, so take weight away from that right lateral beam, you can see that 80% line is now extending far into the bladder. You can also see this on a DVH. So if I drag this up, make our weights equal, then drag it back down, you can see how that changes our DVH. So you can kind of play with that weighting in order to get the plan to look how you would want to. So let's say our goal is to keep that 80% line pretty conformal. So maybe we want something like this. We can see that 80% line is around this box, or this it's going to look like a square because we have these three fields. In order to get more conformal, we would add more fields, but for this case we're just going to stick with our three fields. You can see that we have a hot spot back here. So if I want to only adjust my weighting in the APPA direction, I can lock this right lateral beam, and now if I drag these around, it'll only take weight or add weight to the APPA fields. So let's add just a little bit to the AP side in order to even this dose out. We want this red isodose line right here to disappear. We want this to be more symmetrical in the APPA direction. So it's pretty close. We have now two spots right here, maybe just a tiny bit too much in the AP direction. So there we go, that's fairly symmetrical. Our size of our 110 right here is pretty similar. Close enough. You want to double check how you're normalized. In this case, we're going to leave it at 100%, covering 95% of our PTV volume. You can, of course, adjust that to meet whatever constraints you're trying to meet. But you can see here, with the addition of this right lateral beam, that our isodose lines are very skewed to the right side. So how can we fix that? We are going to add some field and fields. So the way I like to do this is my goal for most 3D plans is to get rid of the 107% isodose line. So what I'm going to do is right click on dose, come here to isodose levels. I'm going to turn that 107 line on in 3D, and I'm going to change it from contour to segment. Just lets us visualize it a little bit better in this window. So I'm going to blow this screen up and add a field and field. So to do that, I'm going to right click on F1, new field and field. So what we just did is we added a field and field plan to our field and field field to our F1 beam, which is our AP beam. And basically what I'm going to do is, since it's too hot over on this right side, for a certain percentage of the beam on time from this AP beam, I'm going to tell it to block this side. Because basically we have too much dose over here, right? So we're going to leave our field open over on this left side for the entire beam on time, because it needs to be in order to get dose here. But over here where we have too much dose, we can decrease that by using this field and field. So I'm going to select the MLCs that I want to move, and I want to move the MLCs necessary to cover this 107% volume. So I don't want to move my MLCs from this side, because look at all this colder area that we would have to go through to get to this hot spot. So I'm going to pick the MLCs closest to that volume that we want to cover. I'm going to select those MLCs using this tool right here, select MLC leaves. Now I'm going to use my shaping tool to tell the MLCs where to go. So I want them to go right around this 107 volume. Just like that. So a good starting point, or usually where I start, is by adding 3% of my beam weight to this field and field. I'm going to recalculate. And you can see when we originally drew this block, we drew it right against the edge of this 107 volume. So by doing this, we told the machine for 3% of the beam on time, or if we looked in here, for 4 monitor units of the total beam on time or total beam MUs, we want the shape of the MLCs to now look like this. So at the very end of this, I'll play the movie that'll show you what it'll look like at the time of delivery, and it'll make more sense. But effectively, we've reduced that hotspot by blocking it for a certain amount of time. So I just added one to the AP side. So now you can see our hotspot on this plane is in the back, and it's a little bit skewed to the PA side. So we're going to add one to our PA beam now. So I'm going to right click on F2, new field and field, and I'm going to do the same thing. Again, when we drew this block, it was right against the edge of this 107 volume, and so every time we do this, we're shrinking that volume. So I like to start with 3%, but you can certainly play with this number. Let's type 5%, see what happens. You can see it got even smaller. 1% stays about the same. So it's all depending on your preference and what you're trying to do, but to start out with, while you're learning how to manipulate the treatment planning system, I think 3% is a good number. It's always a good idea to reevaluate your isodose lines and isodose distribution, make sure it's looking how you want it to. Our 107 is still not quite gone, so let's keep going. So what I like to do is go back and forth, or if we had more beams, we would kind of rotate clockwise and do one beam at a time and reevaluate after every field and field you add. But in this case, we'll go back to our AP, new field and field. So something I want to point out is by turning this isodose line to segment in 3D, it gives you a little bit of depth perception. So if you look at this line right here, this shadow, that's kind of telling us that this part of this volume is closer to us, or closer to the AP side, and then this part is farther away. So if we come look here, this shadow right here that seems to kind of cut through that volume is showing us this edge right here, and then this back portion right here is showing us this edge right here. So what I'm going to do is I'm only going to bring my MLCs to that first initial shadow, or the edge of the anterior portion of this 107 volume, like that. And then on my AP or my PA field, when we make one next for our F2 beam, I'll be blocking this with that one. So again, it's just a method of really fine-tuning your field and fields and getting a really smooth, really good dose distribution. So what I want to do here, if I just type 3% in here, what it's going to do is take weight from both our initial field and this field and field that we created a little bit ago. See that? But I don't want it to take weight away from our F1.0 field, so I'm going to lock that. So now it'll only take weight away from that initial field. Let's do our PA field. So another way to do it is if you just click up here at lock, it'll lock everything, and then I just unselect the top initial field. Okay, there you go. 107 is gone. It is 107 right there. So if we wanted it to actually be below 107, we can just add a little bit maybe to this last field and field. There we go, 106.8. Our 107 is now all gone. We know we have the right coverage because we're normalizing based on coverage here. So we're now done with this plan. But if you look over here, we now have all these beams, right? But we really just want 3 beams. So what we can do is merge these field and fields to their respective initial fields up here. To do that, I'm going to come up here to planning and then merge subfields. So you can see here it's going to put all our F1 field and fields together into one, all our F2s. We did not make any for F3. So this, basically what it does is it copies that plan, merges those fields, and recalculates. So these two plans should have exactly the same isotose distribution, and you can see when I drag these over that those isotose lines do not change. All it's doing is putting all those subfields together into one field. So if we come here and I click this play button, it goes really fast, unfortunately, but basically it's walking through all our field and fields. So for the majority of the beam on time, it's going to be this open field, but at the very end, those MLCs are going to move over into those shapes that we created for a certain amount of monitor units in order to create this dose distribution that we want. And that's it. We can rename our plan, we can add more reference points, rename our beams, but we now have a 3-field plan.